I'm back, and now this is not going to be on the exam. Come back. I don't want you just to turn me off at this point. So I wanted to compare electromagnetism with gravity again. So the particle of electromagnetism is going to be called the photon. A photon is a particle of light, and that transmits electromagnetism. So scientists wanted to have something that would transmit gravity, and they called it the graviton. So a graviton is going to be a particle that transmits the force of gravity, like the photon transmits the force of electricity and magnetism. Well, you should already know what a photon looked like. So a photon, a light, is going to be an alternating electric. So if this is the electric field, then the magnetic field comes out of the board and then into the board and then out of the board and so forth, like that. So this is the magnetic field. Now you should know that the electric field is caused by a electric charge that is, well, I would like to say it's just sitting there, but even a electric charge that's moving will produce an electric field. Okay, so that's what a charge can do. Now, a moving electric charge makes a current, and currents were what made magnetism. So scientists wanted to come up with something that was similar to magnetism for gravity. So if our traditional view of gravity, so remember it's F is equal to big G m1 m2 divided by r squared. So this was the traditional view of the force of gravity, and then from it we could calculate the gravitational field. Well, that's equivalent to the E thing when it comes to electricity. So they wanted to come up with something. What would happen if a mass was moving? If the mass was moving, it would create a second kind of field, like when a charge is moving, it makes a magnetic field. And so they did it. And then they calculated what would be its fundamental constant. If this is the fundamental constant for the regular gravity, then what would be the fundamental constant for this new kind of thing? And so I go into some calculations for it, and you can see that this other constant, the magnetic-like constant for gravity, is really small compared to this one. So that means that for all intents and purposes, you never, ever, 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 ever have to worry about the force being produced by this gravitational magnetic thing. Okay, again, just let that ooze out of your head. I thought it was interesting. Okay, let's take a break. When we come back, let's do Appendix 2.